Thanks for that. Thanks for joining. I want to start with a personal share of an issue that I have in my life. It's really hard for me to connect with new people. Every time even if I need to get service from someone, I always try to find someone else to do that. I need to ask someone at the street where is a coffee shop. I will have a friend to ask that for me. When I was a little child, I have a little brother that used to help me, not for money, but for my good heart. But when I grew up, and as all adult problem, I found myself again and again in a situation that I needed to ask someone new, but I don't know how to do that. And as a good developer, I tried to think, how can I solve that? What is the framework that could help me to solve that? And I found that this issue is something that also exists in programming. And I split it into 4 categories. The chaos, when I need to get someone new, it's overwhelmed me and I can't find the right word. It's also complex because there is tons of ways, languages, methods to connect with new people. The velocity also make it hard, and the confidence that it's hard for me to do. My name is Gabriel, and today we are not going to talk about my personal issues, but on developer problems with getting decisions and policy languages. I am more than 10 years in software development. Last year, I'm doing developer relations in Permit.io. Since 2015, I'm around identity access management. I'm doing mostly authorization, and I've been with policy languages since the first day of Rigo, one of the languages we'll talk about today. Permit.io is a startup for application authorization. We are also doing policy languages, but this is not the main topic for today. First, let's talk a little about programming languages. So back in 50, 60, the way to write programs was, of course, machine code. There is the CPUs were much more physical than today, and the way to write code to them was a binary code, machine code, then assembly. And then people understood that software can solve a lot of problems in our life, and creating software in assembly or in such languages is hard to get. It's creating a chaos on the way that we are producing software. And then there we start structured languages like C and Fortran for specific usages. But after we got more and more software that we need to deliver, these only languages like top-level, high-level languages become unstructured. And then we started to solve this complexity with languages that driven by design patterns like C++, or even if we think like for the last years, so concurrency was a big problem with complexity with usual languages, and then Golang came with design pattern, a very specific design pattern of concurrency to solve this problem. We also have the problem of velocity. The cloud days make us deliver software every hour, even with large enterprises. And this is where we are solving it with framework, right? If we are looking at the serverless and the days of like cloud development, most of the cloud development is not based on languages, it's based on framework. Developers are not JS developers. Developers are not JavaScript developers anymore. And that solved the problem of velocity because a framework can help us deliver very fast software in a confidence way. But this confidence is not always enough because some software is very complex and need to deliver in a high velocity, and hence the declarative domain-specific languages get into the picture. Domain-specific languages help us to deal with a specific problem. They cannot solve all the problems with programming. And because they are declarative, they are hard to declare and they're also hard to mistake. If something is imperative, it creates a layer of logic that is making it easier for people to mistake. Declarative languages create another level of abstraction for people to read and deliver very fast software in a confidence way. One of the most famous example for that is HTML, right? Delivering UI is a nightmare. If you ever wrote a component yourself with like C++, you know it's tons of complexities, required tons of testing, but HTML allows us to write it in only one language. Again, I'll not get into programming or not, but domain-specific declarative languages solve us a problem that were very complex and hard to deliver in high velocity. There is many examples for domain-specific declarative languages. I can talk about like configuration, query languages. There are even languages for creating music. There is an interesting CEL language, which is a language that developed for Google, Common Expression Language, to create some languages for domain-specific. But for the last 4 years, I guess, 4 or 5 years, a new problem rise in the world of application development, and this problem is problem of getting decision. It's never easy to get decision, but getting decision in cloud-native application is getting harder and harder. And this specific domain of authorization or checking what a user or identity can or cannot do is getting hard. Now you'll probably say, programming languages are based on getting decision, right? There is no language without if statements, right? If statement is the most basic one of programming languages because programs or software needs to get a decision. That's true, but when decision getting harder, they became how people writing software, and people like to do complex, simple things. And that's exactly what happened with fine-grained authorization. The way that we are doing authorization, the way that we are doing policy today require much more vectors in the decision we got. 10 years ago, we based on RBAC or role-based access control, we ask if a user has a role and then decide if they can or cannot do something. Today, there are much more data in our world, and we'll get soon to why the problem rise in this way. But getting decision in an efficient way, getting policy decision in an efficient way in our software, getting harder and harder for the last year. But why? So it starts with a chaos, because application, they are not like a one server that I'm copying it file to it with FileZilla. Application now including much more components, and these components has various stakeholders, different way to deliver them, right? So if I remember like 2012, when I started to work in a large enterprise, we had this vertical scaling of VPS, of .NET Virtual Server, and all the software used to be just one component, everything, the thing that related to data. Even the database was like something that is very tight to the monolith. Today, the architecture, first, we have much more challenges because the data that we are processing and the speed that we need to deliver stuff. So in my organization, I have many types of databases, I have many types of code and services, and the way that people accessing these services and front-end applications. So application get a chaos in the way each one of them getting policy decisions. The second thing is about the complexity of the data that we are handling. Again, back in 2010, every application has one SQL DB, and then the NoSQL came. But today, the data that one application processing is unprocessable, right? Just think about for vector DBs or unstructured data. We need to understand that we're not letting user answers from unstructured data that they are not supposed to get access to it, right? And that's not only the case because many problems in software solved with new types of data, right? So for example, we have our audit logs and then we understand that our SQL DB is not enough for that, so we just bring in Elasticsearch or something like that, but we don't think about who can access this data and how we can make sure that all the vectors align when we are getting such policy decision. And more data means more decisions, and that's create what I call like decision fatigue. We have so many decisions, so we are deciding, okay, so either all the users can access to it and do it, or either no user can do it because we follow the less privilege, but that's not the optimal way we want our software to work. We want to make sure that the policy decision we make are very aligned with what our software needs. The velocity also, it's not unique for policies, but policy is sensitive, right? The top one in the OWASP list, for many OWASP lists for the last year, was authorization, the way that we are getting decisions for user, and the velocity of delivering software, and the way that people say, oh, that looks fine for me, I'll just deliver it, and then it pushed to production immediately, create another challenge on the way that we want to inspect the policy decisions that we are doing. And then got the confidence. And the main problem with confidence that I found for the last little couple of years, and I think the exponential growth of digital interfaces that the COVID created us, it make the user really want complex features. Users now, even like consumer users, know to require a very complex technology features. And these features make the user want to own their data. They also have requirement like security requirement. I want to get my data, I want to own my data. We'll get an example soon. But it is not only the users. Also in organization, a large organization or even small, there are much more stakeholders for our code. So for example, we have the DevOps and the platform and all that, not only the product developers, but we have also new professions like RevOps and some, smart BI people that also knows code and they want to push things into our code. And we need to make sure that no data is exposed to someone who does not see that. All this create more complexity to the decision we make. Just an example, to put things on the table, I really like to bring the example of the healthcare applications. Back in 2018, it's not much time ago, a healthcare application was owned by the insurer, by the healthcare company. The doctor has access to my data because the insurer gave them their data. I can't access where is my data. I can't access who is controlling my data. If I get some information about a breach, I just trust the healthcare provider. But today, and that's especially because the digital health that the COVID bring, I am owning my own healthcare data. I know who can get my data. And if I want to give a permission for a nurse or for external doctor to access to my data, it's owned by the user, right? And getting these decisions, now they are fine-grained, require much more vectors in the way that we are getting policy decision in our data. And last but not the least, of course, AI agents, LLMs. Not everyone has the privilege to access an extensive layer of RAG, of retrieval augmented. And making sure that all this AI that some developer just bring into the software because it looks really cool, require us to make better policy decisions, right? So we have these 4 problems, and then we can see how the policy languages solve this problem. So first, from the chaos, we want to get to the structure. So let's understand first where we want to do authorization decision in our software. So the most basic part is the developers and the code. Because of the continuous integration that we have today, we want to control what developers can do in our code, right? Developers, in some form, are users in our applications. A developer that click on a button deliver a new version to all our users. So we want to authorize how process happened in our code delivery. Then became the infrastructure itself. We have many services, could be serverless services, could be microservices, but could be also monolith in multiple languages that speak with each other. And we want to make sure each service has only their own data and their own permissions. Then we have the user itself, the access to the database. We have the data, right? So we want to make sure that non-developer can access the production database, but we also want to make sure that we have a basic level of enforcement and permissions on the database itself, because we could have glitches in the way that we are accessing the data. Then we have, I think, the most critical part, the application code itself, where we really want to enforce unified permissions across all our stacks. And we also have the front end. So I think that, I believe, and I'm saying it many times, that one of the biggest vulnerability is bad experience. Bad experience lead user to try to do something that you haven't planned for, right? So we want to give a good experience in our permission decision in our front end application. So now that we know for these layer models or the structure and the way that we are getting policy decision, we want to get to something that's structured this way. We want to have all our policy configured in one place, and we'll get to soon how to configure policy that is coupled from our application themselves with policy languages, of course. Policy also need data. So to process a policy, we need user roles, we need application tiers, we need many data into that. And this data should be decentralized with the policy engines themselves, the engines that process these policy languages, policy rules. And then if we are deploying decentralized policy engines that get the centralized config and the decentralized data, we can have our application get permissions decisions that we can ensure they are all unified and streamlined to the centralized policy repository or policy code. If we are looking, for example, on the domain-driven design, which I believe is very fit for policy languages and also for security feature, we can think about authorization or policy as a domain. And each domain in our domain-driven architecture is consume only the engine that can get the decision. So we have the domain with the policy config, we have the domain with how to get all the data to get policies, and then all the other services, all the other domain can consume in a secure way all these policy decisions. So with this architecture, we can create a structured way to make policy decisions. But then, how we solve the complexity? We can solve it with design patterns. So what design pattern we can have in policy decisions? So first, let's start with an abstract way we are modeling policy. Every policy decision, we want to get a decision for our policy decision, has three main components. The first one is the policy itself. For example, only admin can perform some operation, right? This is an abstract config of the policy. Then we have the data. The data in our application can also affect, for example, which user has an admin role. It's still very simple, but this data is part of the decision. And then we have the context of the decision itself. So for example, what is the time now? We do not want the users to do sensitive operation on weekends, for example. So now that we understand that every policy decision has these three components, we can have a design pattern of where we are putting every part of this decision. As we say, we want the policy to be centralized, so we know the policy shouldn't be coupled to any kind of data. It should declare the data, but not using it. It should declare how I fetch this data. For example, I'm getting role from my identity provider, I'm getting role with some AAM protocol or standard, but know what is the data. And then we have the context. We know that the context is supposed to be in the enforcement themselves. So when we are getting decision, we are passing the context. And then we can ensure our enforcement of the policy or our policy decision function is a pure function that always get a context from outside and not keep a state for the context. So that's the first way of thinking about design pattern. And then we have the types of the decision. What kind of decisions we want to make? So first is the most simple one, a binary decision, a user allowed or not allowed, true or false. But in a world of data, maybe even more important decisions like data filtering. We want to pass data and we want to get back what data the user has access to or not. Better than that, we want to do, and we'll get to that soon, maybe partial evaluation. We want to build queries that based on permissions. Binary check function, it's very simple. If we are following this design pattern, we can get any kind of policy decision we want to make. We have 4 arguments to this pattern: the subject or the user that want to perform something, the action that they want to perform, usually it's just a string. We have the resource that they want to perform, and we have the context. This way we can ensure that the first 3 arguments are contributing to the enforcement function, the relevant data that we want, and the 4th is the context itself. And every policy decision that we want to make, if we are keeping this function, this check function, this binary check function, as pure as possible, we can ensure every call to this function will get the same result in a reliable way. And we can also model it in our software. We can have this function in any kind of language. So if we are keeping this kind of design pattern, we are saying that our code, our application code, has only check function, has only enforcement function, right? And this way we can ensure that all the applications has the same kind of enforcement function, and they are getting streamlined policy decisions by decentralized policy. More important, like some interpretation of data filtering is what we call partial evaluation. Partial evaluation means because policy languages are a language, right, with abstract search tree, with something that we can process, there are plugins for policy languages that can help us create the queries that will return only what a user is allowed to see. So if we have a policy engine that can process the results of what a user can or cannot do in a tree or in an AST, we can then convert it to any kind of query language. This design pattern can help when we want to give the developers a good developer experience, so they do not have to write themselves the filtering of the data. We can provide them partial evaluation plugins so they can immediately query only what a user can do or can see currently. So we understand the design pattern, and then we have to talk about the velocity, right? So that's nice to say there are policy languages. That's nice to say how policy decision should look, but I need to find a reliable way to define it in a way all the stakeholders, developers and users mainly, will understand that. So there are many policy models, always like end with AC, access control, but I want to talk today about four. I think they cover mostly every kind of use case. The first one is policy-based access control, which is a framework that based themselves only on rules. Each one of them has own limitation and pros and cons, and we'll get to that soon, but we also have role-based access control, attribute-based access control, and now the cool kid in the block, relationship-based access control. Policy-based access control is the most classic for policy languages. I'm using a declarative language to define what all the three components of a policy decision can or cannot do. The problem with like plain policy-based access control is it's really hard to get the data into it. We need to find a structured way to add the data into this structure. Right? So policy-based access control is really good when we do not have that much data, either in the context or the data itself. For example, one of the usage I like to see, one of the usage that actually was involved with policy-based access control is the way that we can monitor infrastructure as code to check developers allow or not allowed to do something, which is actually what the rules can express here. It is a very common usage of policy-based access control. Make sure that developers deploying and delivering only what they are allowed to do. Then we have role-based access control. I think every developers know that. I think it's actually many developers, when they're describing authorization, they say RBAC. We will implement RBAC. We have RBAC feature in our application because role-based access control is very friendly both to the users and the developers. Very easy for us to say, okay, users are segmentized with roles. These roles as policy, what a particular role can or cannot do with particular resources in our application. And this is why role-based access control is so popular. But also, role-based access control is also an issue with making fine-grained authorization. It takes only the users in the account. It's not taking the resources that we want to get decision for in account. And it's really hard to calculate them all together. Just to put it on a diagram, so we have two users, Rick and Morty. Morty has two roles, like a dental member and mobile agreement. I'll continue with the healthcare because healthcare has extensive permissions requirement as a result of the sensitivity of the data. And the roles actually drive what they can or cannot do in the resources. And the thing here, if you think about it, all the granularity is end in the top level, right? The granularity is end with the roles that we are assigning to user. But if we want to calculate also resources and stuff like that, it's getting harder. There are some forms to do that, but then it's not the framework anymore. So to extend the framework, one of the most popular method nowadays is relationship-based access control. Relationship-based access control, we have RBAC, we are assigning role to users, but instead of assigning them only to the users, we will create relationship by a role between a user and a resource. So for example, we can say, Gabriel is an admin of their own data. We are assigning to a specific resource instance, but it's not ends here. If we are creating relationships, we can also create relationship between resource instances. So for example, all my Google Drive files related to each other in this graph, And then if I get a permission, if my policy allowed me a permission for a specific resource instance, I can derive this role across all the resources that related to that. And that's very helpful for extensive data. The main con of relationship-based access control is that our policy need to have this centralized graph. It's not anymore like a centralized language, it is also centralized graph. Relationship-based access control started to gain popularity back in 2019 when Google exposed how they do authorization. Google has a very, today is not unique, but in the early days of the internet, Google has a very unique authorization need. Google has a multiple domain applications. So in my Google identity, I have my own YouTube channel where when I like managing videos. I have my Gmail, I have my Google Drive, and I also, the Google search also saves some information about me and help me to get the right decisions. And there is also the security feature of Google, right? So a couple of weeks ago, my phone was just resetted, and then I lost access to my Google account because they have very strict security on how users should access their account. All these domains need to be connected together to one person. So for example, if I am now getting into my YouTube channel and they want to give me my enterprise account Google Drive thumbnails to upload to my YouTube, they need to find a way to streamline this decision. And then they come with a paper called Google Zanzibar that put some principles for relationship-based access control. This is actually a long paper, and today there are more than 10 GitHub open source implementations for Google Zanzibar, and many like closed source implementation. And that actually track popularity for policy languages or fine-grained authorization. What are the principles of the graph of Google Zanzibar? So first is the relationship tuple. Every entity in our system has a relationship to something. This relationship can create role derivation. So we can derive role across this tuple to create these graph-based permissions. And of course, this tuples graph. And the ACLs, the way that we are creating policies, are based on relationships. So instead of saying like a user with a role can do something, we are saying a user with a role that assigned to a resource can do something on this resource and all the resources that related to it. This kind of could sound complex, so I'll try to make some sense of it. So we have here the same Rick and Morty story, and we can see here that the purple ones are the roles that they have. So at the top left, we can see that Rick is a member of a member group. Member group is a resource that we can do to assign all our member group, let's say family member group, permissions to all the resources that belongs to us, like the medical records, health plan, etc. And as you can see here, in a traditional RBAC, we will have to give Rick or Morty the access directly to the other resources. But with RBAC, we can say, because Rick and Morty related to each other in a member group with the belongs to relationship tuple, we can derive with the light arrow, we can derive the roles into sub-level and potentially endless graph. One of the nice things about graphs is reverse indices, so we can also understand why something is happened. So relationship-based access control is very popular with data-extensive applications, and it's gaining a lot of popularity in the world of fine-grained authorization. Another framework for places where we don't want to store these graphs or to handle data as part of the policy decision is attribute-based access control. Our software built of attributes, right? Every entity, the most basic things of software entity is attributes. What if we can take this attribute and build condition sets based on them? If we can use the policy language to define a condition, then we can use this condition to get decision in a real time. So for example, I can create a condition that only European users that in their daytime can access something. And then in a real time, I can get this attribute from the context, from the real-time data, and get decisions based off it. And one of the most useful stuff of things of ABAC, of attribute-based access control, is actually the way that we are creating deny all rules. So for example, we are creating RBAC system, we are extending it with RBAC, and then we can create deny all based on particular context and stuff that we want to limit our users to do. This is another example. So now that we understand the framework, let's see how can we solve them with policy languages. How can we create confidence to extend all these languages together, work in the design pattern using policy languages. So here is an example of a policy language called Cedar. Cedar is developed by AWS, and it's released as an open source a year ago, I guess. And it's very oriented for application development. So you can see every Cedar rule include these 3 principles in advance, like the principal, which is the subject of the user, the action, and the resource. And then we can also create conditions, like ABA condition. You can see here the when condition. We can combine this attribute to create this fine-grained authorization. The way that a developer looking at this code is very simple to understand. It's a very specific language. You can't do mistake there. It always keeps this flat way of decision or decision configuration. Of course, Cedar also has some cons, and we'll get to that soon. But Cedar is an example how we can create a domain-specific language to solve a very specific problem in a way that we are combine all the frameworks and everything into it. And domain-specific or declarative languages, as I said, has a lot of more benefits. For example, performance. Because we are doing a very specific thing, we can have a very specific performance metrics and have a verifiable way to check that we are always stand in this performance. The validation is easier in declarative languages, and the readability is, of course, easier because users can very easily look at the language and understand what it does. So today I want to discuss about 3 policy languages. The first one is called Rego. It's developed for Open Policy Agent, which is a policy engine. The second is AWS Cedar, that I already show you some example of it. And the third is OpenFGA, is a platform for fine-grained authorization specific for relationship-based access control. So let's start with Rego. This is an example of Rego code. And what we can see here is that we have the first statement. Rego is a language that got inspiration from logical languages like Prolog or Datalog. It's a little harder when starting to work with it because it has to get this sense of logical languages. But when developers gaining this sense of understanding how the logical languages works, it's getting much easier. That's from my experience at least. Rego started back in 2015. Let's discuss about the language and then about the attributes of the language. So the first statement is a whole policy rule, right? And this policy rule combined from 4 statements. The first one is the role. We want to make sure the role is viewer. And then the rest of the 3 is condition. In Open Policy Agent, we can create hierarchy or inheritance of condition, and then we can combine them all into one policy rule. So we have the department that we want to validate. And here you can see that we are getting data from the input, from the context of the document itself. And then we are combining the data of both the resource and the user to get fine-grained decision. Of course, there is not only the input data. You can also just inject data into Open Policy Agent and calculate much more data-oriented decisions with Open Policy Agent. Open Policy Agent is actually not new. It started back in 2015. I just started to write back their policy engine. I checked that back then, but it wasn't that mature. Today, it's much more mature. And the main thing about policy language is it's really multi-purpose because the language is extensive. It has tons of features. You can create any kind of policy agent with Open Policy Agent. Just for example, there is an open source tool called Kix that runs scans on infrastructure as code and based on Open Policy Agent to get policy decision on this infrastructure configuration. There is also application authorization that people perform with Open Policy Agent. There is also a ways that IT departments using Open Policy Agent to get decisions. So it's really multi-purpose language. But multi-purpose language has its own complexity, right? So if you need a policy language for a specific usage, Open Policy Agent is not always the best decision to choose. Here, for example, we can see some domains that Open Policy Agent has solutions for. For example, API gateways. There is a Kong plugin for Open Policy Agent, so you can plug in your policies to your API gateway, get a decision on it. There is also for feature plugging, there is a way to run Open Policy Agent on the browser using Wasm, and then you can get extensive decisions on the browser itself. For infrastructure, for applications, and as I said, for example, for Kix, which is, I think, the way that you can do decisions for infrastructure as code in a very plain way, and also a fine-grained authorization in applications, is show how wide Open Policy Agent is, and Rigo is. Then we have CIDR. CIDR is very different from Open Policy Agent from two perspectives. First, is not a multi-purpose language. It's aimed to have verified permissions in applications. That's the way they create the language. And it also has a very small set of features. All the policy rules in CIDR looks like that. There is no any kind of other feature in the language. The operators are very basic. You can combine nice statements with these operators, but they are basic. And also the data in AWS CIDR is very structured because this is a verifiable language and they have like scientific proofs of policy decisions. If you need high performance policy decisions for application authorization, CIDR is a great choice because developers really easy for them to learn that. The syntax is very easy, it's understandable, it's readable, and it's scientific proof, so you can very easily understand that policy decision stands in their performance requirement. AWS also offered CIDR as a basic for their service called AWS Verified Permissions, which is like a cloud service to do policy decisions. And again, one of the cons of CIDR is, for example, it's not support relationship-based access control. If you want to create this graph, because the way CIDR modeled their data modeling, it's really hard to create hierarchies and reverse indices in this graph, or mostly impossible. So CIDR is very good for application-centric authorization with a lot of context data that do not require that much hierarchies in it. Then we have the OpenFGA. Here is an example of defining policy and resources in OpenFGA. As you can see here, OpenFGA is driven by relationship. It's a Zanzibar-based implementation of a policy as graph. And you are actually configure how the graph looks like. So we can start that we are defining organization. This is actually the most easiest way for people to describe Rebug in a very coherent way is the way that GitHub permissions work. They were one of the first to implement Zanzibar, and they also share how they do it. So if you look into relation-based access control, most of the example you see will be of GitHub because developer knows that. It's a developer product and easy to understand. And we can see here how we are starting with developing relations. We are defining the member, which is the role, and then we are defining the way they are related to each other. So we can see this dash, the organization member, to say that they are related to that, and we are creating hierarchies between that to give more permissions. OpenFGA, in my opinion, is I'll say that the best Zanzibar implementation out there today. It's very easy to implement, it's very easy to start, and it's also configured in a very simple way after people understanding the principles of it. Yet, OpenFGA is very specific to solve the policy as graph problem. If you have more policy problem, it will not be easy to achieve with OpenFGA. Of course, there is option to combine languages together. We'll get to that soon. How to run multiple languages. We can also, for example, use Open Policy Agent for policy decision and use OpenFGA as a data engine for Open Policy Agent. We'll get to it soon. This is actually a summary of the difference between them. Choose Open Policy Agent if you really need multi-domain decisions and you're not afraid or you have enough people to learn this kind of languages. AWS CIDR if you have an application with not much hierarchies in the decision in a very decentralized way, because CIDR best in decentralizing decision in a centralized configuration. And OpenFGA if you need relationship, if you have a lot of hierarchies in your application, OpenFGA will function best. Here is a slide that I share. Many large organizations shared how do they implement fine-grained authorization. A great example that I really like because they date very, very informal is the Reddit one. Everything is just something you can get on Google. Nothing is secret. Each one of these companies shared a lot of material. How do they create fine-grained authorization? You can see some choose Rigo, Uber choose to build their own policy language based on the common expression language. AWS, of course, started CEDAR as something internal for the S3 permissions. So that's okay, but today we are not a language developer, right? There is no Hammer Cap right now. We are framework or platform developer. So I want to introduce you to Opal, which is an open source tool that I'm one of their maintainers. It's Open Policy Administration Layer, and it's a platform that include what we call battery included. So you can plug Policy Engine into it, and then it makes very easy for developers to combine policy languages into their stacks. Let's see how Opal works. So first, Opal has a client and server architecture. The server is the centralized part of Opal. Remember that we said that we want a centralized place to configure policy. So the server is connected to a Git repository where we store all our policy. And it also has a way to configure data fetchers. Data fetchers is a methodology to grab data into the policy engine themselves. Then it has a distribution model to distribute in the data plane the Opal client. Opal client is a wrapped policy agent that knows how to fetch the policy and get real-time updates, but also knows how to fetch data into this policy agent. And when users deploying Opal, they potentially can combine this policy agent because Opal is actually support OPA, it supports CEDAR. We are now having an open issue that we are working on to support also OpenFGA. We also have an issue to support Alpha, another policy language that I didn't mention here. But Opal is like a platform to create application authorization that is based on policy languages without having much strict relation to the policy language. So the feature of Opal, the main thing that we have when we started developing is provide end-to-end authorization that is based on policy as code. It's pluggable policy engine. And one of the nice things is works seamlessly with the GitOps flow. So whenever a user actually deliver a new policy or policy change to the repository, Opal knows to take it, Opal knows to track events and make sure. I prepare a short demo of Opal to see how it actually works. So I'll start with the code. I'll try to do it as large as I can so it will be on the screen. Okay, so the main thing of Opal, as I mentioned, is a server and client architecture. And here we are initializing it with a Docker Compose file, but it also has Helm charts, whatever cloud native methodology you want to choose, you can have Opal for. As we can see here, the first two services is just, let's say, my application services. So I have a data engine where I get all my data from, and I also have the policy repository. So in Opal, you are actually defining what is the policy repository that we want. Because I want to skip the mess of deploying stuff to the cloud, I just define a local policy Git server. But these two are, of course, not necessarily to run Opal. Then we have the broadcast channel, which is like the data of Opal itself. And again, it's not a necessary part of Opal, so I'll skip on that too. And here is the most important part. First, we have the Opal server. Opal server is a centralized server that manages all the policy configuration. First, as you can see here, we are saying this is our policy Git repository. We can define multiple Git repositories, not only one, but I define only one. And we can see this is the branch. One of the nice things about Opal is that we can define different branches for different environments. So for example, if we want to give a good experience for the developer, we can say, okay, if you are pulling a feature branch, you can also pull a policy branch, run your Opal against this particular branch, and then make sure that you are deploying to production only safe and secure policies. And here we also have the data configuration. So as we can see here, we are not bringing the data. We are not pulling the data into the Opal server. We are just defining. So here we say we want to have an HTTP fetcher. And the HTTP fetcher takes this data JSON. And then we can define also topics, how we access this data. We can also define what is the updating mechanism for that. We can have PubSub, we can have gRPC, and there is also many fetchers. There is a Postgres fetcher, there is MongoDB fetcher, there are many fetchers for any kind of data that our clients will need. So this is the server, and here is the client. Here, I am deploying only one client, but of course, as many clients that you want to deploy, so for example, we want to have, there are multiple ways to define policy languages-based decision in stacks, but one of the things is I say, okay, I want data to be really isolated between microservices, and I want each microservices has its own policy agent. And then we can deploy multiple Opal client, and the nice thing about Opal client is that we can define what actually, I haven't defined it here because it's centralized, but we can define what type of data we will have or consume in every one. We can define what is the updating mechanism. It all works. It can be based on Kafka, it can be based on other event-driven architecture. Now the nice thing is I have here the policy, which is the Git repository. It's a very simple blog that I defined. So we have here the policy configuration for admin. Admin can do anything, right? User can only get. So I mapped my HTTP into CDR actions. And the writer can also update policies, right? So I defined a very simple policy. And the nice thing is I have here two applications. One is a Node.js application, and one is a Python application. And each of them has the exact same enforcement of my policies, right? So as we described, there will be these four principles in every policy decision. So we can see that the Python application and the Node.js application has the exact same structure to run policy decisions, right? And this way we are giving very good experience for developers because they are always enforcing the permissions in the same way, no matter how the policies looks like. Let's see it in action. So here I have the Opal itself running. We can see here that the Opal is getting always updates. Here is actually update from the local Git repository because nothing is changed. And I also ran this Python and Node.js application. And here I'll just do a CRL call to create an article with the writer. If you remember, writer can create articles. And if we check that, we can see that the article created. But what if we want to allow only a user with Karma to create published articles? We want writer that did not have the right Karma because it's self-sign-in to publish article. So I'm adding a condition into my RBAC policy here. So here I have RBAC policy, say role writer can post and put articles, and I'm creating condition. I say only if this user Karma is more than 1,000, they can publish. But if it's less than 1,000 and the article published will equal to 3, I want to block this call. I'll commit this one. And again, here everything is in one folder. But of course, in organization, it will be a dedicated folder in a real Git repository. I'll commit this change and push it. And then we can see the Opal logs will soon get this policy update. As you can see here, the Opal updater get a new policy. And now if I'll try to do this call, I'll see this access denied because this condition now block my. This is a very, of course, very, very simple one. It's a very simple and strict policy, very a centralized way to do that, but it's still something that shows how Opal keep it centralized but decentralized with real-time data updates. So solve our problems, structure, design pattern frameworks, and declarative languages, solve any kind of software problem. Hope so. Thank you.